By Julian DeFreitas. What did you eat for dinner 1 week ago today? Chances are you can't quite recall. But for at least a short while after your meal, you knew exactly what you ate and could easily remember what was on your plate in great detail. What happened to your memory between then and now? Did it slowly fade away, or did it vanish all at once? Memories of visual images, for example dinner plates, are stored in what is called visual memory. Our minds use visual memory to perform even the simplest of computations, from remembering the face of someone we've just met to remembering what time it was last we checked. Without visual memory, we wouldn't be able to store and later retrieve anything we see. Just as a computer's memory capacity constrains its abilities, visual memory capacity has been correlated with a number of higher cognitive abilities, including academic success, fluid intelligence, the ability to solve novel problems, and general comprehension. For many reasons, then, it would be very useful to understand how visual memory facilitates these mental operations, as well as constrains our ability to perform them. Yet although these big questions have long been debated, we are only now beginning to answer them. Memories like what you had for dinner are stored in visual short-term memory, particularly in a kind of short-term memory often called visual working memory. Visual working memory is where visual images are temporarily stored, while your mind works away at other tasks, like a whiteboard on which things are briefly written and then wiped away. We rely on visual working memory when remembering things over brief intervals, such as when copying lecture notes to a notebook. The question is, when are these memories wiped away? And when they are, can we still discern traces of what was originally written, or does nothing at all remain? If visual short-term memories are only gradually wiped away, then remnants of these memories should still be retrievable. But if these memories are wiped out all at once, then we shouldn't be able to retrieve them in any form whatsoever. UC Davis psychologists Weiwei Zhang and Stephen Luck have shed some light on this problem. In their experiment, participants briefly saw 3 colored squares flashed on a computer screen and were asked to remember the colors of each square. Then, after 1, 4, or 10 seconds, the squares reappeared, except this time their colors were missing, so that all that was visible were black squares outlined in white. The participants had a simple task to recall the color of one particular square, not knowing in advance which square they would be asked to recall. The psychologists assumed that measuring how visual working memory behaves over increasing demands, that is, the increasing durations of 1, 4, or 10 seconds, would reveal something about how the system works. If short-term visual memories fade away, if they are gradually wiped away from the whiteboard, then after longer intervals, participants' accuracy in remembering the colors should still be high, deviating only slightly from the square's original color. But if these memories are wiped out all at once, if the whiteboard is left untouched until all at once scrubbed clean, then participants should make very precise responses, corresponding to instances when the memories are still untouched, and then, after the interval grows too long, very random guesses. Which is exactly what happened. Zhang and Luck found that participants were either very precise, or they completely guessed. That is, they either remembered the square's color with great accuracy, or forgot it completely. It was almost as if their memories behaved like files on a computer. Your Microsoft Word documents don't lose letters over time, and your digital photos don't yellow. Rather, they continue to exist until you move them into the trash, where they are wiped out all at once. But this, it turns out, is not true of all memories. In a recent paper, researchers at MIT and Harvard found that if a memory can survive long enough to make it into what is called visual long-term memory, then it doesn't have to be wiped out at all. Talia Konkel and colleagues showed participants a stream of 3,000 images of different scenes, such as ocean waves, golf courses, or amusement parks. Then participants were shown 200 pairs of images, an old one they had seen in the first task, and a completely new one, and asked to indicate which was the old one. Participants were remarkably accurate at spotting differences between the new and old images, 96%. In other words, despite needing to remember nearly 3,000 images, they still performed almost perfectly. However, it turns out that they were only this accurate when the new and old images came from